Welcome back to day 2 of parametric equations. I'm going to keep my calculator off to the side for the next thing that we're going to do. But first, we are going to talk about today's goals. We are looking to find a missing coordinate and then evaluate parametric word problems. And always with the video, you can pause at any time and re-listen. So example 1 says we're going to find the missing coordinate in each ordered pair below. So we still have x in terms of t, usually standing for time, and y in terms of t. And for example, this one, I know the y. Okay, so I'm going to plug that y in there. So plug in what you know. You're going to solve for t. And then plug in t to the other equation. Give myself a little more room to write. So for this one, I have 39 equals 1/2 t plus 6. I'm going to subtract 6 from both sides. So 33 equals 1/2 t. To get rid of the 1/2, I'm going to multiply both sides by 2. So I get 66 equals t. Okay. Same idea for the y, or for the next one. I have what x is. So I'm going to plug this one into x. I know what x is at -24 equals 21 minus 3t. I'm solving for t. I'm going to subtract 21 from both sides. -45 equals -3t. Divide both by -3. And I get t equals 5. Now, what I didn't do for either one was plug it back in to solve for the other part. So, after a long day of golf, I have forgotten the next step. For this one, I am plugging t to find the x. Good thing I remembered. So 21 minus 3 times 66 equals x. And for this one, I'm going to plug it in to find the y. I'm going to get my calculator out. 1/2 of 5 plus 6. I thought maybe it would split screen for me. Oops. Hopefully you're going to move past this part. But again, I'm going to plug them in. I'm just going to use a new spot and keep my stuff. So 21 minus 3 times 66 would give me -177 there. And for my y value that I did not finish completing, I have 1/2 times 5 plus 6. So I would get 8.5 as my y value here. So again, do as I say, not as I do. Solve for t, plug t back in. Pause if you need to keep writing. I'm going to try to keep the video short. Okay, let's see if we can solve this one. Delete these two here. I have y, so I'm plugging that in here. 7 equals 4 minus t. I'm going to subtract 4 from both sides. So I get 3 equals -t. You can either multiply or divide both of them by 1. Positive t equals -3. And I need to solve for x, so I'm plugging that in up here. X equals, let's see, -3 squared minus -3. So plus, and I get 12. X equals 12. Again, I went quickly. I may have made a mistake. You should check my work. You should pause and slow down. Same two equations, but this time I have x. So I have 6 equals t squared minus t. Okay. What I need to do now is set this equal to 0. So something we've talked about quite a bit is if it's a quadratic, it should have two answers, and it has to be set equal to 0 to solve. So I get t minus 3, t plus 2, and I get time as 3 and negative 2. I will plug these both in. I will get y equals 4 minus 3, which equals 1, and y equals 4 minus negative 2, which equals 6 plus a positive. Oftentimes, if these are a real world situation, we would say like time can't be negative. I don't have any context to this, so it's hard to enforce that. We're back to the Ferris wheel from yesterday. So I'm asking, I've got them all in here already, and you can see that I did the steps where I put T in for the first one, and then for the second one, I used the letter A. You just can't do them both. And I have a label and a slider. One nice thing is if you want to go with whole numbers, you can always change the step to 1. And then as you move along, it will change by whole numbers. Not that you necessarily need to do that. I'm trying to now slide to the exact time. And when I moved my slider, it stopped at 10 and I didn't get all the way there. So I can say like this goes between 0 and 60. You can click on that and change it. And that way sometimes you get a little bit more of a slider. And I know, oh, there it was. Go back one, go forward one. A equals 15. Now remember, A is really our time. And we're going to say at what time? 15. And if I remember correctly, this was seconds. Okay. So what did I do? I moved the slider of A until I hit the point 21, 25. This one said, what is the horizontal distance to the center of the Ferris wheel when the rider is 10 feet off the ground? So we need to think about our X and Y again. T is our time, our parameter, but we're also moving in time and space, right? Horizontal, the horizon, is my X, and 10 feet off the ground is my up and down distance. So this is my Y, and this is my X. So where is my X when the rider is 10? So I'm going to use my slider. I'm going back to my slider, and I'm trying to, let's see if I can squish this so we can see it all better. Squish it this way so it's a circle. I am going to try and do this, my slider, until I see the Y value equaling 10. Okay, that is not the Y value. That's really close, right? We can make sure that this is not, like we don't have to go by step of 1, of course. So if you do that, you may be able to slide closer to making it 10, exactly 10. Oh, I saw 10. There we go. 9.99, I'm going to call that good. Excuse me. The rider is at the X distance. The point I have is, let's say, 14.7, comma 10. So they are 14.7 feet from the center. Okay, because that was my X value. Determine the height. That's the Y. When the rider is 8 feet left of center. So this time we know the X. So when X is 8. So again, I'm going to slide my slider. Hopefully you guys can see my slider going here. Where is x 8? Oh, I just saw 7.9. So close. I can't get it perfect. There we go. So when x is 8, we'll say that y is like 5.5 feet off the ground. Okay, so he's 5.5 feet off the ground. 5.5 feet, or is it meters? May have been meters. When he's 8 feet left of center. So again, I'm using my slider. So the two topics today, again, were using our calculator and finding the missing value when we knew one of them, and using algebra to find the missing parameter, or find the missing coordinate when we knew the parameter.